everyone, this is the introduction to the grade 9 science curriculum as it is taught in Newfoundland, though it is the Canadian edition. All of this will be able to be translated into French if you're doing French immersion or just want to do it for fun. So this will be a series of videos to help you study and understand the grade 9 science curriculum better, and hopefully we'll get to do math as well. So we're going to start off with basic terms of the universe. There is a celestial body, which is a naturally occurring object in space. So it's asteroids, planets, stars, anything that scientists didn't put there and it just happened naturally. Then there are constellations, which many of us know, and it's just patterns in the sky that are made from the stars. And back in the day, they used to tell tales of heroic stories, animals, mythical creatures, all kinds of stuff. Now we have asterisms, which are smaller patterns within a constellation. So you may have one big popular constellation with a smaller asterism inside. We also have magnitude, which means how bright a star appears to us. So it depends on how bright it is and how close it is to Earth. So like the sun is a very bright star and it's very close to Earth, so we see it as a very high magnitude. There's also angular dimensions, which are ways of measuring stars. You can do this on paper in the sky. On paper is most likely to appear on your test because you don't have any night classes to be in school to do it. And you'll just be given two stars and you'll use a protractor to measure how far apart the stars are and what angle. In the night sky you can use hand patterns, which you can Google or it's in your textbook. And this is a way of telling about what angle. It's a good guesstimate. Now let's talk about the movement of stars. The Earth is constantly rotating on its axis, so the movement of the stars looks different depending on where you are. So in the north, it looks like stars slowly rotate around Polaris, which is the North Star, and it's the brightest. It's found at the end of the handle in the Little Dipper, which can also be called the Little Bear, but its scientific name is Ursa Minor. If you're in the south and looking at the stars, it seems that they rise in the east and set in the west. And some just move directly overhead, like they don't move in any pattern besides over ahead perfectly. Now there's three types of constellations. There's seasonal constellations, and because the Earth rotates around the sun, we see a different part of the sky each season. So that means we see different constellations every season. There's also circumpolar constellations. That's the ones that are below our horizon. It's on the other side of the equator, so we can't see them. There are 88 known constellations in the sky right now, and we can only see 68 in Canada because 20 are below the equator. So unless we go on a really nice vacation, there's 20 we can't see. There's also zodiacal constellations, and those are your 12 constellations that are the sign of your zodiac image. So Cancer, Sagittarius, I'm a Pisces, so my little fish is up there in the sky. I think it's a fish, but usually they don't look anything like what they're supposed to. Now let's talk about planets. There are some requirements to be a planet. So it must orbit at least one star, so like Earth and the other 7 planets rotate the sun. It must be the only celestial body in its orbital path. So each planet has its specific orbital path, and it's the only thing there. There's no other debris or anything in there. And it must be big enough that its gravity causes it to stay in a spherical shape, so that it's not in a square or a triangle or something. So dwarf planets, that's what Pluto is now considered. It only meets 2 of the above criteria. It does have enough gravity to keep it round, and it orbits the sun, which is a star, but it is not big enough to clear its path of orbital debris. So you may be asking, why do we live on Earth? This is a really good test question because it makes you think a little bit outside the box. Today, scientists have only found life on Earth, though it is highly contested. So you may be thinking, I'd love to live on Jupiter. Here's some reasons why that won't work. Planets farther away from the sun are too cold, so it'd be an ice age for us. Planets that are closer than the Earth to the sun, such as Mercury, are too hot, so we wouldn't be able to live there either. In both of these situations, our vegetation, our lives, it wouldn't be able to work. It wouldn't live. It would also take us forever to travel to other planets. So if we wanted to go live in Neptune, it'd be a little difficult because it'd take us, well, we'd be dead by the time we got there. So right now, scientists are only capable of going to the moon because that's close enough. Also, when we're looking at this, we have to think of what the contents are of these other planets. Do they have enough water? What about oxygen? And we're not sure of that right now. So we can't live on them because maybe what are we going to do without water, right? So right now, the Earth is pretty much the perfect fit. There are also satellites. Satellites can be two things. There are ones that scientists deploy, which are like with cameras, they do mapping and stuff like that. Or they can be natural ones, which we commonly call moons. Our planet has one, but some planets have several. There's also asteroids, which are leftovers from the Big Bang. Some are small and are commonly orbiting the Sun in the asteroid belt between Mars and Jupiter. Asteroids are a threat to Earth because even the smallest ones, which could be the size of a grain of sand, could cause enormous damage to the Earth. It could block our sunlight once it gets inside our atmosphere, and they often cross the Earth's path, but thankfully we haven't had too much bad luck with them yet. An elliptical is the path that a sun or any planet or anything travels every day. So comets have an elliptical, and they orbit the sun in a lying elliptical, and they may cause damage if impacted upon a planet. They look like dirty snowballs with a long dust trail made of rock, ice, and gas. So when you're thinking of comets, think of RIG for rock, ice, and gas. An example would be Halley's Comet, and Jupiter has had very small comets impact it and has giant craters left on it because of it. Now there's three types of meteoroids, meteors, and meteorites. It's a little tricky to remember because they're so close, but let's give it a shot. Meteoroids are broken off pieces of planets or other space debris seen as pieces of rock. So it's bigger. Think of meteoroids as bigger than meteors because the word is bigger, it's more letters. Meteors are what people think are shooting stars, and they enter our atmosphere at a high rate of speed and they burn up. So think, because it's meteors, think of a meteor as back in the day, like an old car, like they drive very fast and burn up and they look like a shooting star, like a lightning bolt or something. Think of meteors as chunks of rocks, and every 100 million years one hits the Earth. So think of meteorites as the weirdest word, and it's the weirdest definition. Every 100 million years one hits the Earth. Alright, that's it for today. In the next few videos, we're going to be looking at the early astronomers that philosophized, and we're going to be looking at the sun, going through diagrams and explanations of what all the terms mean, as well as crater impact and what that is. And in the third one, or fourth, I guess, is the first, we'll be looking at space travel and other galaxies. So, just to end off the day, why has Earth won 62 Miss Universe titles when the rest of the universe hasn't even got one? I think it's a little biased myself. Have a great time studying, guys. Good luck.